Hello everyone, my name is Whitaker. I'm from San Diego State University, and this summer I had the honor of working under Dr. Mustafa in the Physics, Astronomy, and Astrophysics departments. The goal of our project was to search for very high energy gamma ray emissions from extragalactic objects in an energy range unexplored so far. Working with data from the High Altitude Water Cherenkov Observatory was crucial to this project, as the Hawk Observatory is currently the gamma ray detector with the highest energy reach, having detected galactic sources beyond 100 tera-electron volts, or TeVs. Blazars, a type of active galactic nuclei, are thought to be the sources of extremely high energy photons and cosmic rays. And although charged cosmic rays have been observed at energies exceeding 10 to the 20 electron volts, their origin and acceleration mechanisms remain unknown. The study of gamma rays, therefore, is an excellent opportunity to study cosmic rays because photons have no electric charge and their trajectories are not bent by magnetic fields. Therefore, they come to us straight from their original sources. Thus, by observing multi-TeV emissions from extragalactic sources, we would be identifying the most powerful accelerators in the universe. We start our study from a predefined list of 16 relatively nearby extragalactic radio-emitting X-ray sources and search for very high energy emissions using data from the Hawk Observatory. This list was created by applying criteria from the 2019 Balmaverde et al. Paper to the sensitivity curve of Hawk. The list was narrowed based on physical constraints of the Hawk Observatory, primarily ensuring that the sources resided in the negative 26 degree to positive 64 degree declination range, making them potentially observable by Hawk. This reduced the number of sources of interest down to 9. Then, 2 more sources were removed because they lacked high-energy gamma-ray data from the Fermi-LAT, a gamma-ray space telescope, and a further 2 were removed from consideration as they had already been clearly seen by Hawk. This left us with 5 sources of interest. These are the maps of the 5 sources using the Hawk data in the multi-TeV energy range. In addition to Hawk data, data was pulled from recent papers from the Veritas Observatory, a major ground-based gamma-ray observatory, the Fermi-LAT, and SED Builder, an online tool developed at the ASI Space Science Data Center to produce and display the spectral energy distribution of astrophysical sources. For each source of interest, the goal was to search for possible observations in the TeV energy range, and in the cases where we found no emission, set up flux limits. One particular source, TON 605, had significantly more data available from previous papers, which allowed for a more detailed analysis. This allowed me to test different empirical spectral shapes, and I found the cutoff log parabola fit had the lowest chi-square value. You'll note 2 fit lines, the lower being the attenuated or observed flux, and the higher being the intrinsic flux, both as a function of the gamma ray energy in the horizontal axis. The observed flux at Earth is different from the intrinsic flux emitted at the source because the sources we are considering are extragalactic, and attenuation due to extragalactic background light occurs in the energy range we're studying. The black and blue points, as well as both fits, are from Veritas and Fermi-LAT data. The purple points and cyan and orange limits come from the Hawk. The Hawk points show evidence of gamma ray emission in the TeV energy range for the first time for this source, and that the energy spectrum then continues to fall off with a steep power law index of approximately 3.7. The limits that I found at even higher energy are hints that there may be an energy cutoff at the source. For the other 4 sources of interest, I fit the available data from Fermi-LAT, and the best spectral shape was a simple power law in all 4 cases. I used the power law index that I fit to set up flux upper limits in the TeV energy range. The limits that I found clearly show that the simple power law spectra do not describe the emissions at higher energies, and that the spectra must have a cutoff below 1 TeV. Hawk data shows 3 sigma evidence that the source, TON 605, is emitting very high energy photons above 1 TeV. This work extends the result from Veritas and Fermi-LAT to energies not accessible until now. A more physical modeling of this source should certainly be explored in the future. Additionally, as more high energy data is published for blazars, and especially for the other 4 sources of interest, the spectral fit for each source can be improved by obtaining more accurate extrapolated values at multi-TeV energies.